Okay, hello Mathcounts friends. The Mathcounts organization has released the state test, and this video we're going to be going over the state sprint round. And today I'm joined by a special guest. It's my son Kenton is going to be joining us today, and he actually took this test, so he's going to be helping me do some of the problems. All right, let's go ahead and jump right in. Actually, before I get into the problems, I want to show some of the results. So these are some of the state cutoffs. You can find this in the community tab or the community pages of AOPS, the AOPS website. And people have gone on there and they've posted what the state cutoffs were and the national qualifying scores for different states. And these are the ones that are listed as of the time that I'm making this video. You can see that some of the states did really well. California, Texas, Washington, New York, Massachusetts. And you can see the total of the qualifying scores here. So California, I think this is actually Northern California, is the highest so far. And overall there have been 4 people that have gotten a 41, which is a really amazing score because the test was quite hard this year. This is their combined score from sprint and target. So yeah, that gives you kind of an idea of what other people have done on this test. I'm going to show you also a histogram of the national qualifier scores. This top bin is 41, so these are the 41s. There's a 40, a few 38s, and so those were the top scores. And then there are some states where it doesn't take as big of a score in order to qualify for nationals. All right, let's go ahead and jump into problem 1. Okay, so this one says Ms. Souza's 4th grade class is going to start a garden project. The field of land the class has to work with is 75 feet by 40 feet. Okay, so it's a rectangle. It's a field. It's 40 feet by 75 feet. And they plan to break the field into 2 by 3 foot plots. Okay, you're going to have these little plots that are 2 by 3 feet. And with no plots overlapping, what is the maximum number of these plots, of these dimensions that they will be able to create out of the field? Okay, so if we're lucky, there will be an integer number of plots that will fit across one side and an integer number of the other along the other side as well. And it looks like that is the case because this side, 40, is divisible by 2. There's going to be 20 of these that will go up this height. And the width here, 75, is divisible by 3. So you're going to have 20 plots high, and you're going to have 75 divided by 3, which is 25 plots for the width. So in order to get the number of plots, we just multiply the number of plots that are stacked up along this edge and the number of plots that are stacked up along this edge when it's oriented like this. So that's 20 times 25. 4 times 25 would be 100, and then you got 5 of those, so you got 500 altogether. All right, I'm going to have Kenton do the even numbered problems, and I'm going to do the odd numbered problems, and we'll help each other out if we get stuck. All right. Kenton?
Okay. So it says Maxwell is signing up for 3 after-school clubs on different school days of the week. If Maxwell is signing up for the math and chess clubs, then how many clubs can Maxwell select from as his 3rd club? So first we find the math club and the chess club, and then since we know we can't have any of the clubs on Wednesday or Monday, since he's already got a club on those days, we can choose from any of the clubs from Tuesday, Thursday, or Friday. And we count those up, we get 6 plus 3 plus 5. And that is 14. So 14 clubs.
All right, excellent. Let's go ahead and move on to number 3. So number 3 says, what is the sum of the 3 distinct prime numbers that are divisors of 29 squared minus 17 squared? When I first saw this, I thought, oh, maybe there's a Pythagorean triple or something, and I can figure out this difference using that. But that's not what's going on here. Instead, the best way to do this is to think of this as an a squared minus b squared. And then, because we're looking for the divisors here, or we're trying to kind of factor this so that we can get the distinct prime divisors, we can factor this into a plus b, which is 29 plus 17, 17, and 29 minus 17. Oh man, I can't write. Okay, so 29 minus 17 is 12, And 29 plus 17 is, let's see, 46. And so we have the product of these two is equal to this. And then from this one, you're going to get two different distinct prime factors, 2 and 3, right? And then from this one, you're also going to have another prime factor, which is 23. And so those are the three prime factors that we have. And we just need to add it up to get the sum of the three distinct prime factors, which is what they want. So 23 plus this 5 will give you 28. And that should be the answer there. Okay, number 4.
Okay, so this one says, Sally ate 2 of her candies and gave half of the leftover candies to her friend. If she has 24 candies left, how many candies did she originally have? So the easiest way for this one is to work backwards. So if you work backwards, you can have 24 at first, and then half of the leftover candies to her friend means that she gave 24 to her friend, and 24 plus 24 is 48. And then from 48, she had already eaten 2 candies, so that means there were 50 originally.
All right, very nice. Okay, that's number 4. Let's go ahead and move on to number 5. So number 5 says, if x plus y equals 5 and x squared minus y squared equals 15, what is the value of x? Okay, this is once again a nice opportunity to use a squared minus b squared equals a minus b times a plus b. So that means that this is going to be x plus y times x minus y equals 15. And x plus y is just 5. We know that here. So that means x minus y is going to have to equal 3. And then what you can do is you can add, because we're looking for x, what you can do is just add these two equations together. And that's going to give you 2x, and the y's will cancel, and that's going to equal 8. And so you divide both sides by 2, and you get 4 for your final answer. All right, let's go ahead and move on to number 6.
Okay, this one says the sum of 2 different positive integers is 8 more than the absolute difference between the 2 integers. What is the least possible value of the sum of the 2 integers? So we can call the larger integer x and the smaller integer y. And so now we know that the sum of the 2 different positive integers, x plus y, is equal to 8 more than their absolute difference. We already called x the larger one, so we know it's x minus y. And now from here, we can subtract x from both sides to leave us with, and add y to both sides, to leave us with 2y equals 8, or y equals 4.
Oops.
So since we know y equals 4, we want the smallest possible value of x such that x is greater than y, since we already said that x is greater than y. But they're different positive integers, so we know x is equal to 5. And the sum of these 2 integers is 9. That's our final answer.
All right, very good. Got 9 on that one. Okay, let's go ahead and move on to number 7. So number 7 says Max is driving at a constant rate of 55 miles per hour. How many miles does Max travel in 3 minutes? So express your answer as a decimal to the nearest hundredth. Okay. So when I saw this problem, I thought, oh, I know 60 miles per hour would be a mile a minute, and that would give me 3 miles in 3 minutes. So I thought, how much slower is he going than that? He's going 55/60ths of that speed, which is the same thing as 11 over 12. So I just multiplied 3 times 11 over 12. And this gives me 11 over 4. This turns into 4 here. And that in decimal to the nearest hundredth is going to be 2.75 because it's 2 3/4. So we'll put that as 2.75. All right, let's go on to number 8. Kenton?
Okay, so it says Yaretsi is baking cookies that have the same thickness. She notices that 10 ounces of dough will be exactly enough to make a round cookie that is 10 inches in diameter. How many ounces of dough does she need to make a round cookie that is 16 inches in diameter with the same thickness as the 10-inch cookie? So the diameter, so we know they have the same thickness, which means that their number of ounces of dough is proportional to the square of the diameter. That's because it's proportional to the area of the circle that you draw from baking the cookies. And so this means the ratio is 16 squared over 10 squared, or 1.6 squared, which is equal to 2.56. So we just need to multiply 2.56 times 10 ounces of dough, which will give us 25.6 ounces. So that's the final answer.
All right, great job. All right, let's go ahead and move on to number 9. So number 9 says Jonathan lists out the first 10 Fibonacci numbers, and there they are. What is the sum of the mean, the median, and the mode of these numbers? Express your answer as a decimal to the nearest tenth. Okay, so the mean, it means we're going to have to add these numbers all up. Now, fortunately, there's a little trick when it comes to Fibonacci numbers, which helps you to add them all up. And that is that if you have a bunch of Fibonacci numbers, I'll just give you the trick for a very short sequence. Like, let's say you want to know the sum of 1 and 1. Now, obviously, it's 2, but another way to do it is to go 2 spaces ahead in the Fibonacci sequence to this one, and then subtract 1. That will give you the sum of all these. So that would be 2 and 3, and you would take 3 and you would subtract 1, and that would give you the sum of all of these ones, which is 2. You can do the same thing here. If you take 2 more spots here, you're going to have 89 and then 144. And then you subtract 1 from 144, you're going to get 143. And I'm going to show you why that is, basically. So there's a recursive relationship. If you can prove that something's true for a very short sequence, like 1, 1, 2, and then you can prove that if it's true for a length n sequence, it's also true for a length n plus 1 sequence, then it's going to be true forever. So we know that it's true for 1, 1, 2. And basically what happens is, for the sequence 1, 1, we know that this thing is true where we can go 2 ahead and subtract 1. So now what happens when we add this next thing here? Well, that next thing is going to be the sum of the prior,
It's the difference.
It's the difference. Yeah, so this thing here is going to be the difference between the next one here and the last one here. So does that make sense? So if I call this x, y, and z, y is going to be the difference between z and x. And so let me just write that out. Y is equal to z minus x. Okay. And we already know that y, well, let's see. We already know that,
It's the difference between 3 and 5, so you have to go to the next one.
I have to go to the next one, yeah. So let's call the next one 5. Let's call that one W, since I ran out of letters. Okay, so let me start over. So z is equal to W minus Y. Okay. And so what I'm doing is by adding Y, help me out here, Kenton. What am I doing here?
So you're adding, let's see, you want the difference W minus Z, because that's what you're adding to the sequence.
Okay, so I can just subtract Y, or let's see.
Add Y,
subtract Z.
Yeah. And then
W minus Z.
Yeah, equals Y.
That's going to be equal to Y. Oh yeah, if you plug this in for Z, you see that that's just Y. Okay.
And Y is what you're adding to the sequence.
Okay, so you're adding W minus Z to the sequence.
Which tells you, so basically the sum you had earlier was Z minus 1, and now you're adding W minus Z to that, and the Z's cancel and you just end up with W minus 1.
Okay, so I had Z minus 1 for my sum before. Now I'm going to add Y, but Y is equal to W minus Z, so I'm adding W minus Z, and now the Z's cancel, and now I just have W minus 1. So now instead of, originally my sum of the sequence was Z minus 1, but now it's W minus 1. Okay, so that was a little bit of a shortcut. Saved you a little bit of time if you knew that. If you had to prove that recursively, it's not going to help you. But if you Well, probably not anyway. If you happen to know that trick, it would have helped you. But for a lot of people, you're just going to end up adding up all these numbers in the Fibonacci sequence in order to compute the mean. So let's go ahead and carry on from there. So we had a sum of 143. There's 10 values, so the mean is going to be 1/10 of that, or 14.3. The mode is pretty easy because there's only one number that exists more than once, and that's 1. So the mode is 1. And then the median, you're going to have to go in between the 5th and the 6th value because there's 10 numbers total, so you can just count over the 5th and 6th value. That's right in between 5 and 8, so that'll be 6.5. And they want the sum of these three numbers, right? So I'm not going to put a box around it because it looks like my answer. So I just add these all up. So this is going to be 21.8. And that is the final answer. Okay, let's move on to the last one in this video, which is number 10.
Okay, so for this one you can call an integer x, y, where x is the first digit and y is the second digit. And that means that we're looking at 36 more than the sum of their digits. So the number xy is going to be 10x plus y. And that's equal to 36 more than the sum of their digits, which is 36 plus x plus y, because x plus y is the sum of their digits. And so now if you subtract off x, you're left with 9x on that side. And then if you subtract off y, then you're left with no y at all because they cancel. And so now you're just left with 9x equals 36. And that means that x, which was the first digit in our two-digit integer, is 4. And so there are 10 numbers where the first digit is 4, because 40, 41, 42, etc., all the way up to 49. And you can tell pretty easily there's 10 of those. So 10 is going to be our final answer.
Okay, excellent. All right, I'm glad I had Kenton with me for this. I can see why you got such a good score on the test, Kenton. All right, I'll see you guys in the next video. Thanks for joining.